Kia ora and welcome to Organic Chemistry as an introduction to level 3. So in this short video I will be going through things that you should know already from level 2. If at any stage you find something that you don't understand, make a note of it. Feel free to email me or contact me through the Wiki Spaces page or through our Facebook page, or come see me in class and I will try and find you some things that will help you. Okay, so here we go. First of all, the golden rule in organic chemistry, because organic chemistry is what we call hydrocarbon chemistry. So there are hydrogens and carbons. Hydrocarbon chemistry. The golden rule is that carbon has 4 and hydrogen has 1. Now if you want a little bit of a background as to why we say this, you go and you think about the Lewis diagram of carbon. So the Lewis diagram of carbon has 4 valence electrons, alright? So it can covalently bond with 4 other atoms. So if I just made all those hydrogens, then I would have methane. They would arrange themselves tetrahedrally and you'd have a, Bob's your uncle kind of idea. So there you go, 3D molecule. Oh, that wasn't a very good wedge. There we go. Wedge dash hydrogen, 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 where all of the bonds are about 109 degrees. And of course, if I was to just draw that in 2 dimensions, it would just be like this. Don't forget that whenever we draw these 2-dimensional diagrams, they are simply a point of a model of how we could possibly draw them. There's another representation of it. Okay, so you need to be familiar with all these types of drawings. Okay, next slide. But the best thing about carbon has 4 and hydrogen has 1 is if you go through and count your molecule at the end and your carbons have more than 4 bonds or your hydrogens have more than 1 bond, you've probably got something wrong. Right, so just to go through the nomenclature, the fancy way of naming things. So the prefixes are meth, eth, prop, but, pent, hex, het, oct, non and dec, but we all seem to get that okay. So we'll go on to functional groups you should know. This is stuff we've done in class already, so if you've already got it and you're all fine and dandy, have a listen one more time, just keep on going. If there's stuff you're stuck on, go back and review it. Okay, so functional groups you should know. Alkanes, alkenes, alkynes, alcohols, carboxylic acids, haloalkanes, and primary amines. Right, we're going to pause momentarily and review each one of these very quickly. Okay, so alkanes, the nomenclature, it ends in ane. Has general formula of CnH2n plus 2. Draw it a number of ways. An example would be ethane, like we did in class. Cool. Alkenes end in ene, alkynes end in ine. These are C2H2N. These are CnH2n minus 2. Examples would be ethene and ethine. Remembering that when you have double bonds and double bonds and triple bonds, you need to number where they are. So this theoretically could be eth1-ine, but because there are only 2 carbons, you can get away with just ethene. These are known as unsaturated. Run out of room. These are this one is known as saturated. Okay, you can't put any more bonds on the carbons. These ones you can, so they are unsaturated. You could put more on. You could make them more wet if you want to think about it as water to, kind of when you're saturated, you can't get any more wet. Alcohols, N-ol is the naming. So example would be, these will be CnH2n plus 1 OH. So it has an OH group. It can have more than that, but basically one alcohol group will be that. So ethanol. Carboxylic acids, anoic acid. Now remember, this is the way that we name them under the IUPAC, and if you want to go find out what IUPAC means, go ahead, it's quite interesting. It's also a good pub quiz question, can be. IUPAC, what does it stand for? So anoic acid, they all have common names, but these are the way that we have to name them, and everyone does it the same around the world. No ifs, no buts, no maybes. So carboxylic acids have the functional group of COOH is how we write it, but it is of course C double bond OOH. Okay, so the example there is ethanoic acid, and you know that as vinegar. These things often smell quite acrid. There's one we will be handling when you do your Easter practical, and it will smell like wet goat, and usually someone spills it somewhere, and can never find it, and my room smells like wet goat for a week. Never mind. Haloalkanes, so these are bromo something ane or chloro or iodo, or what am I saying, fluoro, that was a UBQ, there you go. Alright, they simply have, instead of being saturated with hydrogen, they have either a chlorine, fluorine, bromine, or iodine. Okay, primary amines. That's where I did talk a little bit in class, because these things are fascinating because they are the only basic compounds we come across this year. That means that they can accept a proton. So here I am going to go again a little off topic, well, not really off topic, but go a little bit sideways kind of thing. If I have ammonia, NH3, right, and I add ammonia to water, this will react to make NH4 plus H3O. Nope, wrong way. OH minus. Glad I caught myself there. Okay, aqueous, liquid, aqueous. Now, your equilibrium chemistry should know that this reaction can also go backwards. So you can make NH3 and H2O. Now, if you were to measure this equilibrium lies mainly to the left, so this is more dominant than that, but there is enough of this that it makes a difference. Yep. So if I remove one of these hydrogens and instead replace it with, say, CH3 in H2, this will react in exactly the same way. I've just got a methyl group stuck to it. NH3 plus, remember over here is NH2, and OH minus. Okay? So this is why these act as basic molecules. Okay, so these are, we can either name it as 1-amino, or whatever it is, I spelled that wrong, 1-amino blah ane, or you can say that it is, how do you do this, amine, with a number in there. Prefer this one. It's okay. Alright, stop yabbering. Here we go. Back to the other one. Okay, so that was last year. This year, aldehydes, ketones, esters, acid chlorides, and amides. These all contain the these all contain C double bond O pretty much. Okay, so aldehydes will be R group, which could be pretty much anything really. O, H. This could be H, and if it was H, then that would be meth and Al. Could be another carbon, in which case that would be eth and Al. 3 carbons, propanol. Okay, right, ketones. C double bond O, R dash, where these two are carbons, and they could be carbons of different lengths, and they could be branched carbons. So this could be, for the easiest, simplest one of this one would be prop and to own. Cool. Esters, very cool. I love esters. This is R C double bond O O R dash. Of course, I could just draw that around the other way and have R dash O C double bond O R. Same thing. With this one, you need to figure out where this group is. C double bond O. I usually draw a little bit of a squiggly line in here. This bit comes, the bit with double bond O comes from an acid. The bit with single bond O comes from an alcohol. So we name the acid bit last and the alcohol bit first. So with the single bond O first and the double bond O, so C double bond O last. Acid chlorides is where I just take, instead of having an OH for an acid, I have Cl. Amides, we have C double bond O again in an R group and NH2. These are not basic. Cool. Alright, there is more practice to that and more stuff we talked about in class. If you need to review it all again, come and find me and we'll go through some more stuff. There's some practice for you. We did those ones in class, but you try them again. No harm in trying. If you want more practice at drawing, come up with your own ones. Alright, I'm going to leave it there and talk about reaction types in the second video. Ooh. See you all next time. Bye!